So in this first video, we're just going to look at two simple limits that are going to turn out to be kind of the building blocks for what we do in the next homework assignment. So the first limit is simply the case where we have a function that's equal to a constant. And the claim is that if we take the limit as x goes to any input a of a function that's a constant, that the limit is just the constant. So let's look at this in a concrete example. Let's say we want the limit and we have the function y equals 5, or f of x equals 5. I'm going to switch my pen color here, I think, over to black. So let's say we want the limit as x goes to, you pick a value, let's say -10, and our function is f of x equals 5. So we want the limit as x goes to 10 of 5, and we want to know, what does that limit equal? Well, we come down here, here's -5, -10. And we want to close in on -10 on the x-axis. We let x go to -10 from the left-hand side and the right-hand side. And as we do that, that means we're moving along the graph towards a specific ordered pair. In fact, the ordered pair would be the ordered pair -10, 5, because we would be working with the function y equals 5, or f of x equals 5. So no matter which direction you come in on an input of -10 from, the output wants to be the constant value 5. If we instead took the limit as x goes to 15 of the same function, the function 5, well, that would mean here's 5, 10, here's 15. So if we squeeze in on an input of 15 from the left-hand side and the right-hand side, that means we're moving on the graph from the left and the right towards a specific point on the graph, the point 15, input 15, output 5. The limit is still going to be 5. So the idea is the limit as x approaches any value of a on the x-axis of the function 5, because 5 is a constant, the output is always going to want to be 5. So generically then, we don't want to have to talk about a specific value like 5. If we just say, hey, if the function is y equals c, or f of x equals a constant c, where maybe this red line here represents y equals c, you pick any value a that you want. Suppose a is right here, and then you take the limit as x goes to a, which means squeeze in on a from the left-hand side, take that left-sided limit, take the right-sided limit, squeeze in on a, and as we do that, we're moving on the graph towards a specific ordered pair, and we know what that ordered pair is. It's input a, but the output is just going to be the constant. So big result number one that's going to wind up being a tool that we use in this homework assignment is that the limit as x goes to any input, if the function is a constant, is just going to equal the constant. So that's the first of two simple limits. The second simple limit considers the case where f of x equals x, or if you like to think about it this way, y equals x. And the function y equals x is just the line through the origin, that makes a 45-degree angle with the positive x-axis. So this guy makes a 45-degree angle right here. Here's the line y equals x. And the claim is that the limit as x goes to a of x, the function x, that limit is always just going to be equal to a. So let's look at a concrete example. Let's say I take the limit as x approaches on the x-axis an input of -15, and my function is x. Well, -15 is sitting right here. Here's -15. And if we're taking the limit as we approach -15, that means approach -15 from the left, take the left-sided limit. Approach -15 from the right, take that one-sided limit. And as we punch in on that, that means we're going to be moving, when we move towards -15 here, we're going to be moving up the graph towards a specific point. If we move from the right towards negative 15, we'll be moving down the graph towards a specific point. And what point is it? Well, the x coordinate is going to be approaching negative 15. We're letting x go to negative 15. But because we're on the line y equals x, if x is negative 15, then y is going to be negative 15. In other words, we're approaching the ordered pair negative 15 comma negative 15. So the limit as x goes to negative 15 of x means just replace the x with the negative 15. You get negative 15. If we take the limit instead of x as it goes to, say, 10 of the function x, well, here's 5, 10. We would be right here. Take the limit as x goes to 10, so approach it from the left, which means we're moving up the graph towards a point on the line. Approach 10 from the right, take the right-sided limit, and that will move us down the graph towards a point. And what point is that? Well, it's input 10, output. Well, we're on the line y equal x. So if x is 10, then y is also going to be equal to 10. So the limit as x goes to 10 of x, we'll just replace x with the 10. And so to make it generic, you don't want to have to talk about specific numbers. So we just say, hey, take the limit as x approaches any a for the function x. And what does that equal? Well, a can be any number on the x-axis. And as we approach a, from the left-hand side, we'll be moving up the graph towards some ordered pair. And as we approach a on the x-axis from the right-hand side, we'll be moving down the graph towards a specific ordered pair. Well, what ordered pair is it? Well, when you input a, if we're on the line y equals x, if x is a, then y is also going to be a. And the limit as x goes to a of x, just replace x with the a, and that's the limit. So those are the first two tools that we're going to use to develop our solution techniques for this particular homework assignment.